Mark your own. And Sirkey. Number one, a force of 767 newtons is needed to push a car across a lot. Two students push the car 28 meters. How much work is done if we ignore friction? So my first thought is work equals force times distance, which it is. The force and the distance are in the same direction. So it's going to be 767 times 28. I have no idea what the answer is. Come on, calculator. There we go. 767 times 28, I get 21,000. I'm going to go 21,500, but if you said 21,476, that's okay. Work is measured in joules. I'm going to go 1 mark, all or nothing. You need more time? I can give you more time if you need it. Okay, can you put it face down in block G, please? Thanks, kiddo. Suppose they complete this task in 58 seconds. Power is work over time. How much work? 21,000, what was it, Mr. Dueck? 476 divided by 58. 370-ish. Power is measured in watts. And I think you made a typo. Or you didn't use your answer button. Maybe you went to 21,500 divided by 50. I'd have to play around with it. 1 mark, all or nothing. Okay? How much work is done by a forklift? You know what? Raising, that's another word for lifting. The work is going to be mgh because we're actually giving the piano potential energy. It's going to be the mass, 688 times 9.8 times 2.8. It's going to end up being 688 times 9.8 times 2.8. I get 18,000. I'm going to go 18,900 joules. Psst, I need you to focus here and pay attention. Thank you. Suppose it does this in 73 seconds. It's going to be my answer button from the previous question divided by 73. It's going to be answer button divided by 73, and I get 259 watts. 258.6 I would take. Okay. All or nothing. So far it's been, I think, Cody, fairly plug and chug. Let's get to a little bit of conceptual stuff. Work, is it a vector or a scalar? Lauren. And I'm lazy, I just did that. If you wrote the word scalar, that's fine, but I'm good if you just circle the option. Work is measured in joules, or you could say Newton meters because it's force times distance, or you could say kilogram meter per second squared meters because Newton's is mass times acceleration. I mean, you can keep going, but anyways, most of you probably just said joules. Power is measured in watts, which is also a joule per second, which is also a Newton meter per second, which is also a kilogram meter per second squared meter per second. You can keep going if you want to, but I assume most of you just said watts. What is the minimum power? So they want power. It's going to be work over time. Climbing stairs, the work that you're doing is mgh over time. The time part was pretty obvious, 83. The mass part was pretty obvious, 64. Jada G, 9.8. The tricky part was the height. First thing that I did is I said 21 centimeters. Nice try, Mr. Dueck. But it isn't 0.21 meters. How many steps is this person taking grand total? How many stairs is this person climbing grand total? Yeah, you know what the height's going to be? The height is going to be 82 times 0.21. That's the height. 82, I'm pretty sure. I know. So it's going to be 64 times 9.8 times 82. times 0.21 divided by 83. I have no idea what the answer is. Is it? I didn't use brackets. I don't need to use brackets. I'm missing an 8. I'm missing a 2. That's what I'm missing. And Dina, get off that phone in a big hurry, please. Thank you. Can you move the purse so that you can't hide your phone behind it? Because I sadly don't. I wish I did. Thanks, kiddo. 130. That's better, yeah? 130 watts? By the way, how many of you have ever been on an exercise machine that claims to tell you how much energy you're burning, how many calories you're burning, how much work you're doing? How many of you have been on a machine that claims to calculate that for you, okay? It's nonsense because you need an M in there. You need a mass. And if it doesn't know your mass, that's not going to work. Also, it really it depends on your own body's efficiency and metabolism. So those numbers are garbage. Don't think that somehow, oh, I burned 300 calories and this chocolate bar is 300 calories. So if I eat this chocolate bar, I'll break even because the machine said 300 calories. No, the machine is nonsense, just for what it's worth. Power output of the motor. Power is work over time. You know what? We're lifting. It's going to be mgh over time. It's going to be 25 times 9.8 times 24 divided by 32. 25 times 9.8 times 24 divided by 32. 100. I'm going to go 184. 183.75 watts. And then I think I told you to skip part B, yes? And I think I told you to skip number 8, yes? So that means this is out of, I think, just 7. No, 8. No, 9. I think it's out of 9, yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you give yourself a score out of 9, please? Any lawyering with me? Now is